A fusion splicer, in layman's terms, is simply a sophisticated tool that welds two fiber ends together. Fusion splicers can be used on single mode, multi-mode, 50 micron, 62.5 micron. Any kind of glass fiber, not plastic, but any kind of glass fiber can be, two fiber ends can be welded together with a fusion splicer. And we're going to show you how it's done. We'll show you how it works. Now, what are the reasons to use a fusion splicer? Well, the first one is if you're doing single mode fiber in, say, a data center, and from one telecom room to the next or one rack to the next, that customer is going to want the absolute best in the lowest loss and the lowest reflectance in any fiber connections. So to get that, to achieve that, use a fusion splicer, because what a fusion splicer does is takes two fiber ends and puts them together and welds them so that there is no more end. What was two becomes one. And because of that, there is no reflection, back reflection, and there's very, very little loss. So that's what they want when you're hooking up stuff for high performance single mode fiber. Now, another reason to use a fusion splicer is to repair a broken fiber. A fiber that's broken or dug up, the quickest way to do it is with a fusion splicer. Now, this assumes you have a fusion splicer to use. The third reason that fusion splicers get used is sometimes we're bringing a heavy cable like this one, this outdoor cable, into a building. And when we bring this into a building from another building, when we're bringing this in, we need to transition it onto indoor fiber. This cable is illegal to install in a building. This cable is legal. So at some point we have to hook these fibers up to these fibers. Typically this is done with fusion splicers, and it's done, the splices are done, they're put into a splice cabinet, which I'll show you in just a bit. But this is another reason to use a fusion splicer. And the other reason to use a fusion splicer is that you can take You can buy pre-installed connectors from some companies, and they look like this. And there'd be a connector on each end. Now these would be factory made, they'd be perfect. Now for that customer, being yellow, this is single mode fiber, for that customer who wants the absolute perfect, or as close to perfect as the connections can be, you'd buy these factory made connectors, and there'd be a connector on each end, typically you buy them 6 feet long. Then you cut them in half, and this makes a pigtail. And from here, we fusion splice on the fibers, and we have a perfect connector, and we have extremely low loss splice here, which the net result is a very low loss fiber optic link. Now, if you have a fusion splicer, you'll use it a lot because it is the quickest, most convenient, and best way to put on pigtails and to do fiber repairs and to do fiber splicing. That said, fusion splicers are not inexpensive. The one I'm going to show you is around $1,700. So they've come down dramatically in price. They used to be $15,000 when I started training in fiber 15 years ago. But now there are new splicers out that are more cost effective, but it's still a relatively high cost item. And as you'll see with the mechanical splice video that I'm going to produce, that will be in this series, you can get by with mechanical splices for most all multi-mode work, and it's much lower cost in terms of the equipment and the things you need to get into doing the mechanical splices. As with all fiber optic installation or working with fiber optics, we have to take safety into mind, and we have to use the correct safety equipment. So we're going to be wearing our safety glasses, and we're going to be using the fiber optic disposal bottle, which you've probably seen in other videos in this series, and this is where we dispose of the broken fiber pieces. The fusion splicer that I'll be demonstrating with is the EZ Splicer. This comes from a company called Fiber Optic Resellers, and I believe they're in New Hampshire. You can look them up on the internet. This is a splicer I bought very recently, last year. The good news about splicers is that even old ones will, if properly used, if you know what you're doing, even an old splicer can work perfectly well. In all my training I've done, the splicer I used to use, and I have recently retired, it was built in 1992, and I was still using it in 2017 to do training classes. So, and it still works. It works fine. Just have to know how to work it. But let's talk about what comes in the kit with the EZ Splicer. First is the splicer itself. This is a machine, and you'll see how we use it, load it, and that sort of stuff. This guy here, this is a precision cleaver. This is a precision cleaver for cleaving fibers. Now, this is a higher quality cleaver than the one that we used for the Brilliance connectors. There's a cost differential as well. This type of cleaver typically costs $400 or $500, but it is included in this kit. Now, they have a set of fiber optic strippers, which I'm going to use some different ones because I don't really like these very much. This is battery operated, or can be battery operated, and this is a charging pack for it. Battery operating is very nice, very convenient. When you're in a hole in the ground, 60 feet from a building somewhere, nice to be battery operated. So that's what you get here. And we have these, what I call cassettes, and you'll see how these are used in detail when we do the fiber optic, when we do the fusion splice. But these are magnetized, and these are what are going to hold the cleaved fiber ends as we load them into the splicer. And so they have a set for multi-mode fibers, and they have a set for single mode fibers, okay? Or actually 250 micron fiber, which would typically be the single mode stuff. It would have no 900 micron outer jacket. That's the difference. These are for loose tube fibers that have no outer jacket directly attached to the glass, and the blue ones are for when we have the 900 micron, and we're going to be doing the 900 micron today. And we also have some heat shrinks, which you're going to need. And a heat shrink's got a little metal rod in it. There's an oven in the splicer, and the oven is going to cook the splice when we put the heat shrink over it, and provides protection for the splice after it's done. And what else have we got? We've got our alcohol wipes, and remember, if it's not cold and wet, it's not an alcohol wipe, and you need plenty of these. Now, my experience with fusion splicers is you can normally use an alcohol wipe for like 5 or 6 splices in a row, then you need to open a new one. Your splice quality will start to degrade after you've wiped it, you've used this wipe 5 or 6 times. So you need a bunch of them if you're doing a bunch of splices. And the last thing we've got is something else that's not in this kit, but we've got our disposal bottle, and we'll be using some of the tools from the West Penn Wire Brilliance connector installation kit. We'll be using a couple of them to do our termination and to do our fusion splicing. To test our fiber link that we're going to use, which is this gray one here. Now remember, this is just a short little jumper that I made, but the actual fibers you'll be testing might be 1,500 feet, 2,000 feet long, whatever. And to test it, we're going to use the Ideal Fiber Master tester set. This is the light source. We turn the light source on. We turn it to 850 nanometers because we're testing multi-mode fiber. You can also test multi-mode fiber at 1,300 nanometers. And we turn on our meter itself. Come on. And you'll see that it says null because there's no light energy coming to it. And then we're going to connect up our test leads, which are these blue test leads. And we're going to hook them up. I've got my Scotch tape out here so I can clean them. Clean one end. Come on. Come on. Clean the other end. Okay. And now we will hook our 2 test leads together and see what we get on our meter. Our meter is reading negative 6.1 dBm. That's decibels reference to 1 milliwatt. When I press the 0 button, it zeroes them out. So now it is 0 dBm. So now we're good. So now we're going to take our jumper that we're going to test, the gray one. We're going to remove the dust caps, and we are going to clean them on the tape. And now we're adding to the equation the two connectors, the two West Penn Brilliance connectors, and another barrel. So we disconnect from the hookup we had before. We add the barrel. We hook the barrel up on this side. We take one side of the test jumper that we're using. We hook that up. And then we hook to the other side with going into our meter. And we're reading negative 2.5. We're reading 0.3 or 2.5 of a dB of optical loss on our meter right now. So that's how much loss. And we're going to write that down. When we started with this thing, we had 0.3 dB of loss. And it's important to also notate at what wavelength we tested at. We tested at 850 nanometers. So this is how we test our fiber before, in this case, to show you what the Fusion Splicer will do. Okay, what I've done is I've cut my jumper that we just tested at 3 decibels, 0.3 of dB of loss, and I've cut it in half, and I have stripped one end to show you how it works, but I've stripped one end. I'm getting ready to cleave it. Now, with this particular splicer, it comes with these cassettes. I call them cassettes. You can call them something else, but what these are is they're magnetized, and they fit into the splicer specifically. There's a right side and a left side. They fit like this. Okay? I hope you can see that. This is where they fit in. Okay? And so we're going to load our fibers in with this, with these cassettes. So we'll do the left side first, and they're labeled 900 micron left because this is 900 micron fiber. And let me just point out to you that there's an electrical arc that occurs when the splice is made, and so you want to make sure that you don't use this inside a manhole. Very, very important, because that electrical arc could ignite explosive gases and pretty much ruin your day. The other thing I want to point out to you is that when you clean the fiber, before you cleave it, you want to make sure you're using the 99.9% alcohol wipes, and you only want to clean it one time. If you clean it more than once, you'll leave alcohol on the fiber, and if you do, sometimes when you gets in the splicer, the fiber actually, like the alcohol catches on fire, which isn't going to ruin the splice or anything like that. At least I've never had that experience, but it'll ruin the splice, and that's no good. So now this precision cleaver we have here, and you can see if on the side here, you can see actually the diamond wheel blade. Okay, this is what is that going to actually cleave the fiber. Now this cleaver is set specifically for this splicer. That's why it's in the kit. And there's no measuring involved. The cassette fits in the cleaver like this, and then you drop the top of the cleaver, which gravity took care of it for me, but it fits in there at the exact right length it's supposed to be. Then we simply push the button, pop it open, and our cleave is done. And now we can remove the cassette. Now, when you are doing fusion splicing, very important. First of all, if the splicer is not in use, the cover's closed. Or better yet, it's closed and in the box. Okay? You never leave this thing out to get dirty. You never want the insides of this thing to get dirty, or you're going to have problems. That's number one. Number two, when you are getting ready to load the fibers, or you've cleaved the fiber, immediately it goes into the splicer. You don't set it on the table and go get a Coca-Cola or something like that, or go take a break. No. You load it into the splicer right now, because you don't want it to get contaminated in any way. Fusion splicing is, super accurate and very sensitive to dirt. So we want to eliminate as much as possible issues of dirt. So I'm going to take this one and I'm going to load it in here. And then I'm going to close this. Now I'm going to turn my splicer on, which I guess I should have done before. And you see fiber optic resale corp right here. Now it's going to come up and it's going to tell you in the corner it says MMF, so it's multi-mode fiber. So it's saying it's ready to do multi-mode fiber. And you can see the cleave. You can see the cleave fiber and it looks perfect, right? It's perfect perpendicular. It's perfect right angle on the end of the fiber. So this is how we prepare the fiber end to get it ready and how we load it into the splicer. Off camera, I prepared the right-hand side. I stripped and cleaned and cleaved the fiber for the right-hand side here. And you'll notice here I installed a heat shrink. I slipped it on here. Now these heat shrinks come in different sizes. This particular one is a 60 millimeter one. Those are the ones you want to get. You want to get the longer ones. The 40 millimeters, not so good. Hard to fit sometimes. Anyway, so what we've got here on the screen of the splicer is you've got the two cleaved ends, and now this is the beauty of the Fusion Splicer. The beauty of it is that once you've cleaved the ends, and you take a look at them, and they're perfectly 90 degrees, they're looking good. Once you look at them, then the machine takes over. The machine does the rest. So here you see it says splice. It's set for multi-mode fiber. I press the splice button, and now what you're going to see is the two fibers will line up. You'll see some measurements underneath and overhead, and then you'll see there's the electric arc. That's the arc that is melting the two ends of the fiber together, and they're being pushed together. Then there's a pull test, estimated loss of 1/100th of a dB. Notice down here it's flashing, it says oven. This is the oven up here. This is where we put our, this is where we're going to put the heat shrink in. Now here is where you have to be very careful, because you just have bare glass now welded together, and you want to make sure you don't cut it on something. So you real gentle, like you have to lift up that's the camera and the light for it, and then you flip up the little chrome holders on the cassettes. Come on. And now we have this is our splice right here. You can see it. There it is. And it's pretty strong too. I'm pulling on it. It's pretty strong. So now I take my splice cover, my heat shrink, I slide it over the splice, making sure that I get the whole thing in there, and it's in there and it's protected, and I drop it into the oven. Let me get this little holder up. Drop it in the oven, close the lid, and press the oven button. Now you see it's red up here because it is actually heating the splice, and it's making the heat shrink so that it tightens up around the splice and the 900 micron jacket. Now if I'm getting ready to do another Fusion splice, what I do is I take the cassettes out, I put the camera back down, and then I press the reset button, and the reset button resets the machine ready to do the next one. So once it looks like the splice is done, and we can pull it out. So we pull the splice out, and here you see our heat shrink has melted onto our splice and melted onto the jacket of the fiber, and so now our splice is protected with the metal rod that's in here and the plastic heat shrink. Now that we've completed our Fusion splice, we should retest it to make sure that it's good. To do that, we fire up our Ideal FiberMaster test set again. So we turn on the light source, because we're testing multi-mode. We turn it to the 850 nanometers. You might not be able to see that, but that's what it says there. And then we turn on our meter, and our meter is going to say null. It says null because there is no light energy coming into it. And now once again, I'm going to zero out my meter. Anytime you turn off the meter and or turn off the light source, you need to re-zero the meter. And once you've zeroed the meter, you need to leave these turned on until you're done testing everything that you're testing. Okay? So I'm going to clean the fiber end. I'm going to hook the light source into the meter, and it's going to read those -6 dBm, -6.2 dBm, something like that. And I'm going to hit the 0 button. It reads 000 dBm, or pardon me, dB. Now, I'm going to take my spliced jumper that I just made. I'm going to clean the fiber ends on the tape, on the Scotch tape. And I'm going to hook these into my tester. Remember, when we tested this originally, it had 0.3 of a dB of loss. So we hook this into the tester, and let's see what we got. Well, now we're reading 0.2 of a dB of loss. So obviously, keep in mind that every time you hook up fibers into adapters or into barrels, they hook up a little bit differently. Nothing in this world's perfect, and there's a little wiggle room in here, And so this is very common that, you hook it up again and you'll get a slightly different value. But if the value is within 1/10 of a dB, it's no concern. Okay, it's just the way it is. But this thing is reading now. It's reading negative 0.25 dB. Okay, so we did the fusion splice onto the jumper, and we added absolutely no loss to the fiber link that we have. So this is how we retest to make sure that our splices are of high quality. In fact, now it's reading 0.3 dB, so it's exactly the way it was before. So that's what we got. Once your splices are completed, they need to be mounted, and there's any number of different boxes and ways of mounting that come from the manufacturers that build these things. Here you see I have a dozen fusion splices that were done, and you see this black thing in the middle. These are little rubber foam fingers. Okay, so these splices are held in here with the foam fingers, so that holds the splice. The box protects the splice, and there's a wide variety of these boxes, wall mount, whatever. There's some that are clamshells, there's outdoor ones, indoor ones, underground ones. There's all kinds of splice holding boxes. But the key is that your splices are being held securely. And this is 250 micron fiber, so you see the way that I put it in here. I wanted to make sure I wasn't getting any micro bends, that I wasn't excessively bending the fiber. And this particular box, when you use fiber-specific boxes, okay, they are going to have what's called wire management or fiber management hooks. So there's a hook here, there's a hook here, and then there's places to put tie wraps here and here, and all that put together gives you a way to mount securely, to secure the fusion splices, and also to secure the fibers coming into the box and make sure that they're not going to get tangled up, and make sure that they're not going to create micro bends in the fiber. So this is now I will point this out. In an emergency situation, if you're doing either fusion or mechanical splices, which is on another video demo that we're going to have here, if you have to duct tape it to a beam in order to just keep it up and out of the way so nobody steps on it or breaks it as a temporary measure, that's what you do. When you're doing a repair to a fiber, whatever's going through the fiber is likely the most important data that the customer has, and the customer is going to want their fiber back up and running ASAP. So you go out there, and if you've got a fusion splicer and you know how to use it, you can quickly repair the fiber, and then you can, if you have to tape it, I've wrapped them in garbage bags outside and put police tape around them, on sticks, do not touch this stuff. And then I told the customer, hey, we got to bury this later. Of course, I was doing it in the middle of winter. We couldn't dig because the ground was too cold. But the point is that you can do these temporarily, protect them in any possible way. But to finalize the job, to do a correct, what we call fiber restoration, your splices will end up, whether they're mechanical or fusion, they'll end up in holders, these rubber finger clamps similar to these, and then they'll be in a box of some type. So you've seen a demonstration of using a fusion splicer, and you've heard of some of the benefits that fusion splicing gives to fiber optic connections, in that you get extremely low loss and you have no reflectance, and if you have the right tools and you know what you're doing, very fast to do, very accurate to do. I would just say this: if your company becomes deeply involved in fiber optics, you're going to want, or you may need to have, a fusion splicer. You may have some customers, particularly if you're in the datacom world, you may have some customers who require fusion splicing. They will not accept mechanical splicing. So if you're going to be a pro fiber optic company, you'll need a fusion splicer. Thanks for watching this video, and look for the other videos that discuss and show and demonstrate different aspects of how technicians work with fiber optics.